Welcome. Today I want to present to you the new tool we're releasing called Praeda-II, Printer to Plunder. The purpose of Praeda-II is to create a multi-function printer auditing tool that can be used to scan a network environment for multi-function printers and identify those printers that are potentially at risk or vulnerable. My name is Daryl Hyland. I am the Principal Security Researcher of IoT at Rapid7. I have over 25 years experience in IT and IT security. For the last 10 years, I've worked at Rapid7. Last 8 years, mainly focus on research for security and IoT technology.
Hi, my name is Sam Moses. I'm a security consultant with Rapid7. I work on the penetration testing team. I've been doing cybersecurity and cybersecurity testing for 10 plus years. Enjoy it. It's great. As part of it, I am actively doing engagements and on internal engagements where I do interact with and test with printers. So for Praeda-II, we took the name from Praeda from Latin, which means to plunder, spoils of war, booty. So, pirates, Vikings, awesome stuff like that. And Praeda-II is designed to be a data harvesting tool for printers and to figure out what booty we can plunder from the printers. We test them for various weaknesses and known configuration files, other known vulnerabilities, and we take all that information after scanning the printer, and then we output it into a log structured so that it's easy to be parsed and imported into other tools. So when we were designing Praeda-II, we designed it with the idea that it could be used by both blue teamers so that they can scan their attack surface and get an idea of what printers are on their attack surface, as well as what vulnerabilities and misconfigurations are on there to be able to secure their environments better, as well as pen testers like me, so that when we are testing people's environments, we can know and focus on printers that have known vulnerabilities, known misconfigurations, or potential weaknesses that we can leverage to be able to get information to either escalate or pivot or be able to manipulate in other ways to gain further access into their environment. So, history of Preda. There was an original one, which is why we are Praeda-II. The original version was developed in 2011. It was written in Perl, and it was actually presented at Blackhat Arsenal in 2014. Sadly, after a few years, around 2017, it started lacking support, and so it fell out of date. New printers come out, they weren't being tested and scanned and imported in, so that it was losing its effectiveness and basically diminished as a reasonable functional tool, which is why we are rewriting it now. So back then, Praeda-I did a lot of good testing. It tested for default passwords, passback attacks, which is basically when someone goes in, has access to the configuration settings of a device, in this case, multifunctional printers, and they set it up so that when someone goes and tries to log in with the service, instead, when they log in, the password that they log in with will be passed back to our server because we set it to come back to our server instead, and we can harvest credentials from people as they try to log in and use that then to gain access to other resources in the internal network. It also tested for known code exploits, configuration files, and potentially pull them down and they might have hashes in it, things like that that were known vulnerabilities. So that was 10 years ago, and the years leading up to that. Now it's 10 years later. Not a lot has actually changed. Some vendors have improved the way that they do default passwords. Instead of doing really default stuff like admin password, we now use serial numbers, and that's great. There is an extra step in trying to get the serial number for these printers. And so it's not just a simple admin type it. There's passback attacks are still a very viable attack for a lot of these printers. There are new multifunction printers features, which potentially can also open up new attack vectors like the remote console. There's also code exploits, which never really go away. And so it's always good to stay patched when it comes to these printers and doing it. And so we designed it to be able to test for those type of code exploits and known vulnerabilities and see if they exist. And so that whether a blue teamer that needs to be aware of their attack surface and which printers are actually vulnerable, so you can focus, or whether you're a red teamer that needs to focus on their printers that have vulnerabilities and stuff, because we're doing time box testing. You got a week to test an internal network. You need to focus on where the juicy parts are. There's a printer with a known vulnerability. Get in there, and you might be able to, you can get credentials and start pivoting and going even more critical resources. So it's great.
Thanks, Sam. So next, let's go ahead and talk about Praeda framework, the actual tool itself and how it's put together. Praeda is actually written in Python, unlike the original tool, which was written in Perl. Praeda-II is in Python. There's three main pieces to this actual framework application. There is the main Praeda.py file, which we're looking at right here. That particular file takes input from a couple sources. We can feed a target list to it. We can feed a mmapscan gmmap file to it, or we can feed a CIDR input into it, a /24, for example. We'll show that in more detail here in a little bit. The second thing about this framework is you also have a data list file under a data folder. This is a fingerprint flat file that contains SNMP fingerprints, server fingerprints, HTTP title fingerprints, things like that. The third part of this framework is the actual modules. These are the jobs that actually go out and gather information like address books and test for default passwords and check to see if SMB is enabled or if LDAP is enabled or many other things as you're running this auditing tool. So let's go ahead and dive in a little closer to the actual application itself and take a look at it. So here we are. Let's go ahead and look at this. This is actually installed in here. As you can see, we have the Praeda.py, we have the data folder and the jobs folder. So let's run Praeda without any syntax. And we quickly see the various syntax that can be fed into it, which is three of them. We can actually feed a gmmap file into it. We can feed a flat target list file into it, or we can actually send a CIDR to it and then set various parameters like project folder name, the actual output log file data. We're going to go ahead and change over to the actual data file folder. We're going to look at that. So here we have the data list. The data list, like I said, is a simple flat file, but is it a fingerprint file? So the first part of this is just a tracking mechanism. It doesn't mean anything. Anything could exist in there. But over here is actually the fingerprint data. Now this is actually SNMP. So when the product actually queries a device and it returns this field within the SNMP identifier for the device, it'll run the following jobs. MP test is a simple just fingerprint job, doesn't do anything. But as we get down into the Xerox VersaLink C7, which is a C7025 or C7055, the different versions of that, when it identifies that via SNMP, it'll actually run three separate jobs in this case. And we'll go ahead and take a look at those jobs here in a minute. But as you can see, we have a number of fingerprints in here, and we also have several that actually have defined jobs with them. And we're hoping to have a lot more soon. So once we get over into the jobs files, we have currently 11 jobs, 10 jobs that carry out something, and one just generic fingerprinting job. So let's go ahead and look at this. We'll look at the first one as an example. This first one is for a Xerox. Xerox is going to default password check. So it's going to check for defaults on the passwords. And currently it's been tested against these models. As we test it against more VersaLink models within the Xerox series, we'll add them to this list and make sure they're flagged in the data list file. But again, this does a couple checks. One is it checks for a default password of 1111, which is a common Xerox. We also will check for the serial number. So we set this thing up to query SNMP to pull back serial number data on the device, and we'll check it for the actual serial number. So there's two checks this does. If 111 fails, it tries the serial number on the device. The next one we want to look at is 0002. This one here actually pulls down the address books. Again, it'll query the address books. And on top of that, it'll check to see if any of the user accounts within the address books are configured to carry out SMB scan the file functions. Why would we look for that? Often, if a misconfigured system exists out there and SMB is actually set up, it is possible to either do a passback attack against SMB or do a relay attack against a Windows environment using that SMB data. But it's all based on if there's any vulnerabilities. Again, the purpose of the tool is to identify the probability that a device could have a configuration that could lead to actually being able to carry out various attacks against a network environment. The last one we want to look at is number 3 in this series that we showed. This one here actually checks for what's known as remote control. The new versions of Xerox have a functionality that's known as remote control. Remote control is like standing right at the printer. The console, the keypad, everything that's on that printer and that functionality becomes available through remote control. Typically, remote control is only enabled through the administrator console. So you have to log on with default 111, serial number, or if the company set a complex password, you would have to log onto that to get access to remote control. In this particular case, remote control can be enabled for unauthenticated users. So it would be a bad configuration or insecure configuration if somebody implemented it for all users, because no users have to be authenticated to actually use this if it's enabled. It's not enabled by default. Somebody would have to configure it that way. This particular tool will query this OID and identify, is it turned on for unauthenticated users or not? That is a quick overview of the current architecture.
So the Praeda framework is designed to test these printers once they're being tested with different modules. For example, there's a module to test default passwords. With testing the default passwords, we test to see whether the default password is like admin or admin password is enabled. It can also do things a little bit more complicated. Like, for example, if we know that that specific printer has the serial number as the default password, we would go in and actually have the program test to see if SNMP is enabled. And if SNMP is enabled, try to pull that serial number from the SNMP. Or sometimes you can get the serial number through the web interaction. And so we'd see if the web interface is enabled and you can pull the serial number through there. And so we would test to see if you can pull the serial number from those locations. And if you can, then is it still set up as the default password? And then if it is, you would be able to test and know just with running Praeda-II whether it is the default password as the serial number or not still. So that's how these different targeted modules are designed. We have different ones for like users in address books, where if you can find the address book, then it will download the file and actually be able to have the list of users in a CSV file. Some printers have known vulnerabilities, so we'd be able to set it up to test for that, test whether LDAP's configured. And so if you learn LDAP's configured, you might be able to do passback attacks if you're a pen tester. All the different things for the printers, Praeda-II has been designed to be able to do it where this printer is known to have these things. You can then design the module to target the printer for those things once it's been identified. And so that way it's adaptable and can change as needed, as well as be targeted for the printers once they've been identified as well. And then it's all output in a way that's easy to read, easy to parse, and easy to use. For example, here's some of the example outputs. The first one is the downloading of an address book. So it did find that the address book was enabled, and then it downloaded it and stored it in a CSV file. So not only would you know that it was enabled, you now have a CSV file of all the addresses and the usernames that you could potentially use. You also have the unauthenticated control here is the example for number 2, and it shows that it is enabled. And so you know that you can potentially get in the remote control and see what you can do with that and see what you can run. It also tests for passwords with see whether it's default credentials or not. So in this one, we set it up where it's default credentials. You log in, you run the tool, and you can actually know the default credentials. So they're right there. And so now you can log in and actually mess with the device configurations and various things like that. The last one is an example showing that the output of LDAP is enabled. So knowing that LDAP's enabled, and if you can go in and edit it, then you can actually adjust it and change it, and then actually start doing passback attacks and see if you can harvest credentials.
Okay, let's go ahead and run the tool. Let's see it execute. We're going to run it against our test environment where we have a couple multifunction printers. And let's go ahead and see how it works, and then we'll try to explain out some more detail of the actual tool. As you can see, we're actually going to run the tool on a Kali image. We highly recommend you run this on Kali. The reason why is it deals with OpenSSL. You will encounter a number of printers that are running deprecated SSL or deprecated Diffie-Hellman certificates. In those cases, they'll end up throwing errors. The newer Python has protections to prevent that. Most of that's driven out of OpenSSL. Kali has actually compiled OpenSSL to be able to handle the older stuff. Because if you run this on a system without that, you may be forced to deprecate those items, which will put your overall system at a higher level of risk. And we highly recommend you don't do that. Kali is the place to appropriately do that. It's ready to support the tool 100%. So we recommend to do it from there. So let's go ahead and look at this. We see we have a gmap file. So let's go ahead and cat that gmap file that was run against our network for the devices that are existing on our actually network. And what it'll do is we'll take that as a feed into Praeda to actually run in this environment. So let's go ahead and run Praeda. So the first one is the core Python script. And then, as we mentioned earlier, the different settings. -G will let you feed a gmap in. And then you create a job name. And that'll create a job folder to hold everything. And then you can give the log output. So it'll break it down into folder and then the various logs. So you can run it in the same project job folder and create different logs and different outputs. We highly recommend that. So we're just going to go ahead and run this against our environment and see how well it does. So it's pretty straightforward. It's kind of an interesting thing as you see the error we have down here for 443. The current Konica that we have configured does not have 443 or SSL enabled, but the actual device still actually has a port with SSL that it responds to. But when you try to carry out an SSL connection to it, you obviously get a remote disconnect as being invalid. We've put checks within the application to protect against any issues associated with that. So the application should continue running even when it encounters odd SSL issues on devices. So as you can see here, we're able to output to the screen some interesting things. Our admin password was not 111, happened to be the serial number. We also pulled the address books down. Here's the name of the address books, and we'll actually show that. So we have address books that are actually pulled down. It'll also check in that address books to see if SNMP scanning is actually enabled with any of those accounts, which could, based on security reasons, lead to potential attack vectors that we need to think about when we're trying to secure our printer environment. Again, this field right here is the IP, the port number. This is the full fingerprint. Remember, we were actually pulling a subset of that, Xerox VersaLink C7, and that would trigger the module to actually run. In this case, we scan the same device twice, both non-SSL and SSL. So you'll get double accounts when you do that, and a device is configured to take both 80 and 443, not uncommon. And then also we come over here and we had remote enabled, control enabled on the actual device so we can test for it. And we were able to do that. And then the Konica also tested here for a default password. So let's kind of look at this data. So if we come over here and we can see that we created an Arsenal folder. So let's go ahead and go over to the Arsenal folder and look at what was actually created. We actually created address books. So let's pull the address books down. Let's go port 80 on. And we see it's comma delimited type information. So you do not need to authenticate it on a VersaLink to be able to get this address books. And it's a wealth of information that's potentially exposed. So it gives us the ability to audit and see what kind of data we're actually exposing there. And then we have target data. Anytime there is a parsing taking place, we'll actually gather all the target data as a process, and then this target data is used to actually run the actual targeted scans. So we have a breakdown, a list after the GM map is actually parsed, what ports, whether it's HTTP, HTTPS, that are actually done. We also have our test log, but we're going to look at the web host log. So if we cat test one web host, this is very useful. In this case, it's kind of limited. But as I mentioned, this tool goes out and it looks at all HTTP, HTTPSs that are fed into it and queries SNMP. So this will go out, even if it's not a printer, and gather that data on the actual device. So this web host file may be very useful for eventually creating new fingerprints or identifying new things that are on the network that can be built into the actual tool. So it's a wealth of information. And then let's look at the actual log. So the actual log is more of a formalized breakdown. If you look at the README on the Git, we've broken down what this first field is, this one. One, I think, is a default password check. Two or zero is the check for some other stuff. Four is to actually see if there's an address book. So we're trying to build a parsing environment. There's some fields out here that have not been filled in, so there's nothing added to those yet. Those are for future expansions. One of the future expansions we want to add in there is to be able to reference back to Metasploit modules that may be useful to further test this particular finding within the audit tool. So breakdown, we have remote control, and it gives us the IP address, the port, and we see here that remote control is enabled for unauthenticated users on the device. So I think that gives us a general idea how the tool works. Now, as this tool grows and has more features, and as the community helps us build out more fingerprints and more modules to test for those key things that we've already mentioned, LDAP, SNB, default passwords, various other features or functions, address books, all of those type of things, we want to continue to build on it. We don't want to build the attacks or exploits into the tool. We want to do that in Metasploit. Metasploit is the place to do that. But we want this tool to be able to be run against a network that may have 100 printers or even more, and be able to identify all those without having to individually go to each one manually to identify that.
So we designed Praeda-II for the viewpoint so that multiple people can get good use out of it. Pen testers like me, we can use this in our time box engagements to be able to focus and narrow down on the vulnerable printers. So if we find printers in our network as we're testing, we can use Praeda-II to either find those printers, or actually, if we do find them with our just normal network scanning and things, we can go and scan those networks. This is really helpful because some of the more and more networks are getting secure. People are locking it down really well. Printers might still be overlooked. And so if you can identify a printer with, let's say, LDAP enabled and you have access to it, then you can go and edit the configuration file, set it up for some passback attacks, and then continue testing some other things. And then while you're continuing testing those other things, you're watching, and if someone logs in that printer, you can get credentials, and then boom, you have a foothold. You can then start pivoting and escalating and seeing what you can do with those credentials and actually move forward more in the network. Let's say that they've secured LDAP, but they have an address book you have access to, and you can actually download that and from their configuration files. And then you have a list of usernames. And if they secure their environment, you're not really finding any way to do that. One way that we commonly get foothold still is password spraying. And so if we have all that information, we have a list of usernames now that we can start performing password sprays with and see if we can guess those credentials. Security auditors can use this tool to look over the corporate security of the whole entire network and be able to identify these printers. And these printers will also be identified with known vulnerabilities, misconfigurations, and things like that. So it'll allow them to be able to do a quick look over the organization's whole printer security posture. And then also, of course, IT support. So they can actually keep an eye on their printers with different new vulnerabilities and things as Praeda-II with continued support stays up to date. You can be scanning these printers for misconfigurations and make sure that the printers in your environment are actually more secure, therefore securing your overall environment better too. Now, there are some continual improvements and developments going on with Praeda-II. We are improving the communication timeout. There are some printers that when you connect to, we've noticed that it kind of hangs and holds. And so we've been improving the timeout feature for that to make sure that it properly does time out. And then you can continue scanning when you're scanning a wide range of printers. So that way you're not just hung up on one. Handling out-of-date SSL and TLS devices. If you run this on Kali, there is no issues. But if you want to run it on a different system, like Ubuntu or Windows or anything like that, there are some changes that need to be made. So there's some improvements that can be done for handling SSL and TLS devices that are out of date. Output parsing and importing into other applications. Down the line, we would love to see being able to actually flag it for different tools and things, or you can even set it up for a custom tool. So if you have that way, it immediately comes out in the format needed for that tool to be read into and then do that additional testing. For example, Metasploit. Tagging Metasploit has a lot of different modules built for testing printers, doing passback attacks and different things like that. And so it would be really great to be able to tag those modules in part of the parse data. And then with that parse data, you know which ones to do. So continual testing of printers and knowing which ones actually tie back to those Metasploit modules, they can be added into the Praeda-II framework and be able to make testing and even easier for pen testers or security auditors, or if you need to prove it as an IT support, you can use that with Metasploit and show those different vulnerabilities and weaknesses.
Thanks, Sam. So what is the future of Praeda? The goal is we want to expand the features and capability of it. So we don't want to take anything off the table. The goal is to take feedback from the community. How do we make this tool better? How do we take it to the next level? How do we make this the tool that pen testers go to evaluate multifunction printers? Auditors go to these things. Internal blue teams can actually go to this and get a good picture of potential risk or vulnerabilities within their multifunction printer environment. That's where we want to actually take this tool. To be able to do this, we need community support. To be successful, we're hoping to get feedback on the tool, but not only that, we need other people to develop modules for this. Do you have a printer on your network that is not in the tool? Then go ahead and figure out how default passwords work, how LDAP works, SMB works, or any other feature that you think is critical from a security standpoint, and create a module and a fingerprint for the tool. Hopefully you will have this on Git and you can put pull requests to be able to make that happen. If not, you can always reach out to either me or Sam and send us that data. And then we can put it in the system and put it in line to be tested by other pen testers to become active. This is how we make this tool successful, by growing it and making it a useful, valuable security assessment auditing tool for the community at whole. And in conclusion, here is some reference data. So here is where the current version of Praeda resides. I thank you much for watching our presentation, and I highly recommend you go out and download our tool, give it a spin, tell us how to improve on it, and write modules to help the tool to grow. Thank you very much.